Okay, this is another quadratic, but we're going to do extra information on this one, okay? So let's start with the basics. Let's get our inverse function. Y is equal to 7x squared, x is equal to 7y squared, x divided by 7 is equal to y squared, y is equal to the square root plus minus square root of x divided by 7. So q minus 1 is of x is equal to plus minus the square root of x minus 7. And inside the square root sign, you cannot have a negative sign, which means that x must be greater than or equal to 0. Positive or 0, not negative. Beautiful. Okay, now let's go and sketch quickly. I'm going to pause, sketch, and come back. Oh, wait, let's do the table first, okay? So here we're going to do our xy table. I'll do it here and I'll say x, y, and then over here we'll do xy as well. Now on my xy, on the black one, I'm going to go 1, 0, minus 1, which means on here I've got 1, 0, minus 1. Now I can solve for y on the black one. 7 times 0 is 0, 7 times 1 is 7, and 7. And on the other side, I'm going to have 7, 0, 7. Okay, let me sketch quickly. Be right back. All right, so there we go. We have our two sketches. This is the q of x, and this is the q minus 1 of x. And our axis of symmetry, y equals x. Okay, now based on this, let's do additional information. So the first thing we want to talk about is the concept of whether or not this is a function. What is a restriction? Now, if you remember the vertical line test or the definition of a function, our definition of a function says that each input gives one output. So over here, if I look here, 1 gives me only 7 as an output, and negative 1 gives me 7 as an output, but it's only one output for each input. Whereas on this one, I have two inputs that are identical, and they give me two different outputs. So this is a problem. So what I'm trying to say to you is if you do the vertical line test, you will notice that going down there, I cut this at two places. And going down there, I cut this at two places. In other words, q minus 1 of x is not a function because for every x value, there are two y values, which is not allowed to happen in a function. Am I saying it the right way? Yeah, for every x value, there are two y values. Okay. Now, the first thing that you need to know is whether it is a function or not. And for the most part, the graph that looks like the parabola that looks like that will be a function, and the parabola that looks like that is not a function. The second thing you need to be able to do is to make it a function. So I need you to be able to give restrictions to make it a function. Now, when you give restrictions, you will start with the blue one. You will start with the q minus 1 of x, but it applies to both of them. You can't have a restriction on only one. It has to be on both. Now let's see what this means. If I go to my Desmos calculator, you will notice that on the graph, I have y equals 7 to the power of x, and then I have y equals the square root of 7 over x. And on the picture, the blue line does not complete. And the reason why is because it's not a function. So if I did, no, this one is wrong. It shouldn't be that. It should be squared. So this should be 7x squared. I'm thinking it looks wrong. There we go. Okay, let's remove that. There we go. This is what it ought to look like. So we have these two lines. The red one is a full function, the blue one is not. Well, on the sketch, on the calculator, it is a function, but it has a restriction, and the restriction is it does not go below 0 on the y-axis. So it's only positive for y. So let's see what this means for us. You can have two possible scenarios, okay? If we're talking restrictions, your two scenarios could be looking like this. If your graph goes like this, then your inverse of the graph will go like this. That's one scenario. Okay. Your second scenario would be is if your graph goes like this, then your inverse function will go like this. Okay. And you need to be able to put those restrictions in writing. So if we restrict on the first option, the black graph, let's talk domain and range restrictions, right? So domain is your x values, and your x stops here. There's nothing on the right. So according to this graph, your domain means that x is greater than or equal to 0, where x is an element of all real numbers. Wrong bracket. If we did a range restriction, that's your y. This is the lowest point, so nothing below this, right? So that means that here, your range restriction is going to be y is greater than or equal to 0, where y is an element of all real numbers. These restrictions means that both the q and the q minus 1 are now functions, which is good. Now let's look at the second one. If we wanted to do the same thing, we want to input restrictions that will allow us to have a function in both, right? Now this one is tricky. If I'm using my Q graph and I draw my horizontal line on the Q graph, so the black line does not go this way, if you can see that. And the blue one does not go on this side. That's important. So the domain here, if I say, let's say Q and Q minus 1, okay? For domain, I can say X. So what did I say? We don't go in the positive side, right? Only negative X. So X is less than equal to 0. And for the blue graph, X is only positive, not negative. So my domain here says X is greater than equal to 0. Here they are different. What about range? Let's have a look. On the black graph, so that's my y-axis, right? Black graph is above, so it does not go below. The black one does not go below, so that means it's only positive. Y is greater than equal to 0. And for the blue graph, it doesn't go above, so it's only negative. Y is less than equal to 0. Those are my restrictions if I wanted to make them positive. If I wanted to make them both a function. So this is important that you are able to do that. Define whether or not it's a function, and then make it a function by imposing restrictions, and your two possible scenarios are on the screen.